Okay, here we are with the first of the sessions for the functions and relations revision. Again, it's a sheet that I've handed out in my class and for the students to work through. The first one we have here is a circle graph, and we're told to find the coordinates of the centre and the radius of the graph. Now, to find the x-coordinate, what we need to do is identify the x component of the equation, x plus 3 squared. What we can do is we can take that bracket and set that equal to 0. If we rearrange that, we'll take away 3 from both sides. We end up with x equals negative 3. So that's the x-coordinate of the centre. And for the y-coordinate, we take the y component of the graph. Again, we'll set that equal to 0. Y minus 7 is equal to 0. Add 7 to both sides, that'll give us y is equal to 7. So the centre of this particular graph will occur at negative 3 and 7. That's the centre. And to work out the radius, what we do is we take the square root of this. So the radius will be equal to the square root of 16, which is 4. What is the equation of the circle that has a diameter with endpoints at 4, negative 5, and negative 4, negative 5? So this tells us that with the graph that we have, with our x and y coordinates, that's going to be at 4 and at negative 4 and negative 5 on the y-axis. So we have an endpoint of the diameter here, and we have an endpoint of the diameter here. So that tells us that the radius of the graph is 4. So either way from there it's 4. So it's going to be a circle that passes around like so. So the centre of the graph will occur at 0 and negative 5. That's the centre. So if we have the centre at 0 and negative 5, that tells us that our equation is going to be x squared, because it's not translated left or right any direction at all, plus, and this will need to be y plus 5 squared. And we're told that the radius is 4, so this equation will be equal to 4 squared, or we can rewrite it as x squared plus y plus 5 squared is equal to 16. And that's the equation for that particular graph. And we'll move on to the next question. If a and b are real numbers, what are the asymptotes for the graph of y is equal to 1 over x plus a squared take away b? What we should do to start with is we'll take the bottom here and we'll set that equal to 0. Now you can use a square if you want to. We can go x plus a, I'll use the square, equals 0. Take the square root of both sides. That gets rid of the square, so we just have now x plus a still equal to 0. Take away a from both sides, it gives us x is equal to negative a. So the asymptote, one of them will be x is equal to negative a. And the second one we use for our vertical translation, which will be the negative b. y equals negative b. So the two asymptotes that we'd have with this one would be x along the line of x is equal to negative a, and the other is along the line of y is equal to negative b. Now the next question that we have here, which of the following is the equation for the graph of a circle? Now the thing that we should remember is that a circle graph needs to be in the form of x squared plus y squared equals the radius squared. So if we look at the first of these equations here, we need to, well, basically all of them, we'll probably need to rearrange them. The first one, if we add x squared to both sides, we'll end up with x squared plus y equals 49. We haven't got y squared, so that one's out of the picture. The second one of these graphs, if we get the x squareds and the y squareds on the same side, we'll have to subtract x squared from both sides here. So this will leave us with y squared take away x squared equals 49. It's not in the form of x squared plus y squared, so that one is certainly out of the picture. The next one, no need to rearrange it, we've got x plus y squared, so again it's not in the order, it's not in the form of x squared plus y squared, so I can rule that one out as well. The next one, we have x squared take away y squared, so again it's not plus, so I can rule that one out. And we'll do a rearrange for the last one here. We're going to add x squared to both sides, so if we add x squared, we do end up with x squared plus y squared is equal to 49, which is in the format that we need, so E is the correct response for this particular question. And on to the last question for this particular section. What are the equations of the asymptotes for this particular equation? So for the first one, we have a vertical translation of 5, so we can say that we have one asymptote for the equation will be y is equal to 5, and for the second one we need to take that part there and set that equal to 0, so 2x take 5 equals 0. Add 5 to both sides, we have 2x is equal to 5, then divide both sides by 2, we'll have x is equal to 5 over 2, or 2.5. So the equations that we have for our two asymptotes, and these are the lines with which this particular graph will not exist, are y equals 5 and x is equal to 5 over 2. Now, to have a bit of an idea about what that means, if we were to sketch a graph, we have our y-axis and our x-axis. We would have an asymptote along the line of y is equal to 5, so along this line here, where y is equal to 5, and then we have another one along the line of x is equal to 2.5. Normally draw those as dotted lines. And the graph will approach but not actually touch either of those two lines. And if you've got no idea of what the shape of the graph is going to look like, then you can plot a few points. If we have x is equal to 5 over 2, so if we were to substitute 5 over 2 into there, what that means is the bottom line there is equal to 0, and we'd have 1 divided by 0, which is undefined. So that's why you have an asymptote at that particular point. Corresponding one will be y is equal to 5, where it'll approach that line but never actually touch it. If I pick some x values either side of 5 over 2, and we will be able to find a few points. So first thing I might do is, if we say pick 0, x is equal to 0. So if x equals 0, we'll substitute that into the equation. 2 times 0 is 2, sorry. That will tell us that y will be equal to 5 take away 1 over negative 5. So that would equal 5 and 1/5. So when x is equal to 0, y is 5 1/5, so it's just a little bit above that horizontal asymptote that we had. If we get rid of all that now, we'll have a different x value. If we have x equals 1, then y will equal 5 take away 1 over 2 take 5, which is negative 3, which will be equal to 5 take away 1 over negative 3, which will equal 5 1/3. So just a little bit higher up. That's obviously out of scale now, isn't it? And what I've just done is stopped, just for the sake of time, to calculate a few other points. When x is equal to 2, we would have y was equal to 6. And when x is equal to 2.2, y is equal to around 6.67. When x is equal to 2.3, y is equal to about 7.5. When x is equal to 2.4, y is equal to 10. When x is equal to 2.45, we see y approaching 15. So that you see, the closer that the graph gets to that vertical asymptote, the steeper and steeper it gets. So we end up having a graph on the negative side which looks like this. It's really steep. Goes up like so, and with as it approaches negative infinity, it'll get closer and closer to that horizontal line of y equal to 5. And then when we go the other side of 2.5, x equal to 2.5, so when x is equal to 2.6, that's when y is equal to 0. So that's in about here somewhere. When x is equal to 3, y is equal to 4. So it's up around here somewhere. And what ends up happening here is we get the same sort of shape of graph. So, press things out like that, and so it'll get closer and closer and closer to the asymptote the closer it gets to there, and it'll come around, and obviously my scale's out a little bit, so it's good for you to plot a few points. Another little trick that you can do is you can actually type this equation up here, just type it into Google, and it will give you a little graph that you can interact with. So it'll give you a little dot that you can drag along. So you can type that in for any number of functions, and Google will actually produce a little interactive graph. You can drag the dot to compare different x and y values, and that is a little tool that you can use just to help you get familiar or become familiar with the shapes of different types of graphs. Okay.